All right, so good morning, welcome back. I hope we had a wonderful break. So let's take our look at the calendar. Not a whole heck of a lot left in the calendar. There's the end of the calendar. Today, 26, we are graphing parabolas again. It's our second day on graphing parabolas, and then doing some problem solving. Coming up on Wednesday this week is the review for test number 2. So I have no plan for that day. You're just going to practice and study and make your reference sheet, whatever you want to do. And then our second and final test is on Friday coming up. It is definitely not too early to start studying. This particular test is going to cover everything on the quest that I just handed back. So hopefully you've still got that fresh in your mind. But it's going to cover a whole heck of a lot more. It's 14 to 26. Taking a quick look back here at the calendar. 14 starts way over here. Pythagorean theorem and laws of exponents, roots and radicals, all of that good stuff, everything since test number 1. So roots and radicals and polynomial stuff, and then all of the new things about factoring and graphing parabolas and solving quadratic equations. It is on a lot of stuff. It could be intimidating, but the test is not tomorrow or even the next day. It is 4 full days from now. So come up with a study plan to help you get ready for that test on Friday. Any questions on the calendar? Okay. Let's take a look at page 211 here. So on page 211, we've got our summary at the top. In this lesson, we solve word problems that involve maximizing or minimizing a quadratic equation. So I'm going to give you a new way to do an old thing. So let's take a look at this parabola over here. Just looking at that graph, can you estimate the x-intercepts? 2 different numbers. Looks like x equals 1 and -6. Everybody agree? Okay. So if I wanted to find the vertex, what would I do with those 2 numbers? I would average them. Okay, so let's do that. So let's find the x-coordinate of the vertex by averaging the answers we got in part A. So here we go, x sub v, x-coordinate of the vertex. So we average, so that means 1 plus -6 divided by what? 2, right? Add them up and divide by 2. So -5 over 2, or if you prefer decimals, -2.5. Does that seem reasonable looking at the picture? That the vertex here happens at x equals -2.5? Seem right? Looks good to me. Okay, and then to find the y-coordinate, you would plug the -2.5 into that original equation at the top of the board. There's nothing new there. So this is how we used to find the vertex. I'm going to give you an easier way to find the vertex. Here is the easier way. You guys remember the A, B, and C from the quadratic formula, right? Let's write them for this equation. How much is A? 1, right? The number touching x squared. How much is B? 5. And C? -6. It's important to grab that negative. Okay, so A, B, and C. So I'm going to give you a brand new formula to find the x-coordinate of the vertex. Here it is. The x-coordinate of the vertex is given by -b divided by 2a. -b divided by 2a. So in our example, -b, what are we putting? Page 211 in the packet. 211. So we're putting -5, right, because it's -b, so -5, divided by 2 times what number? 1, and we get -5 over 2. How does that compare to what we got when we did the averaging? Compares pretty darn well. It's exactly the same thing. So this spiffy new formula is an easier way to find the x-coordinate of the vertex. -b over 2a is a really, really quick thing to calculate. Additionally, finding the x-intercepts is typically a hard process. It was easy here because it was a picture. We just grabbed the 2 numbers, the 2 x-intercepts from the picture. But typically, if I give you an equation and I say, hey, graph the parabola, you don't have the picture. The picture is the last thing that you get, right? And so how would you normally find the x-intercepts? Well, to find any x-intercepts, you'd let y equal 0. So I will temporarily put a 0 right here. And then say, hey, you got to use the box method to factor that, right? That finding the x-intercepts is the biggest process in graphing a parabola. And this fancy formula for the x-coordinate of the vertex bypasses the need to find the x-intercepts, right? We just go directly to the vertex by doing the negative b over 2a. Okay, additionally, this opens us up to being able to graph a whole new slew of parabolas that we couldn't graph before. So for example, suppose that there was a parabola like this. You don't need to write this part down. How many x-intercepts does that one have? None. So the old way for finding the vertex there fails in this case, right? If I asked you to find the vertex, we wouldn't be able to do this until this moment because the old way was to average the x-intercepts and there aren't any x-intercepts. But does that parabola have a vertex? Sure it does. So the only way to find the vertex is the fancy new formula, x vertex equals negative b over 2a, okay? Additionally, suppose that I told you that we do the process and we find the vertex, and suppose that the vertex turns out to be right up there. And suppose that you also discover that the parabola opens upward. How many x-intercepts do you expect to have? None, 0, right? So don't spend any time trying to find them, right? We can do up or down easily, that's old. We can now do the x-coordinate of the vertex easily, that's new. And armed with those two pieces of information, you might discover, hey, there are no x-intercepts at all, so don't bother spending any time trying to do the box method or trying to do the quadratic formula, both of which are lengthy processes, okay? This is a time saver for us. Suppose that the vertex was up there somewhere and we discovered it was down. How many x-intercepts are there? 2, and so you got to go find them, right? But you know you're not going to be spinning your wheels looking for something that doesn't exist. Suppose now that the vertex happens to be right there and the parabola opens up. How many x-intercepts are there going to be? 1, that one. And you already found it. Again, don't spend any time trying to find the x-intercepts. In this case, if the vertex happens to be on the x-axis, then it is the only x-intercept. So don't spend any time doing a hunt for other x-intercepts. Suppose that it was there and the parabola opens down. That's still the vertex. How many x-intercepts? 1. It's still that one. Suppose that the vertex is here and the parabola opens up. How many x-intercepts? 2. So you spend time going through our techniques to find them. And now suppose it's there and the parabola opens down. How many x-intercepts? None. Don't look for them. Okay? All right. So new and improved order for finding the, for graphing a parabola. It's right here. We're going to go through this real quick in words and then you'll practice with it in the activity. I just want to compare the old process. I've written it over there on the side. So we'll see how they're the same and also how they're different. So step 1 is to decide if the parabola opens up or down. Same or different? Same. Step 2 is to find the y-intercept by plugging x equals 0 in. Same or different? Same. Step 3 is to find the x-coordinate of the vertex using our fancy new formula, the negative b over 2a. Same or different? That is different. And our fancy new formula is simpler than what we were doing before with the finding the x-intercepts and averaging them, okay? So from here forward, it's going to be different. So here, we figure out where the vertex is, and then we decide whether there are 0, 1, or 2 x-intercepts based on just thinking about the picture, right? Like where the vertex is and whether the thing opens up or down completely determines whether we should be hunting around for x-intercepts. And if there are no x-intercepts, then you don't look for them. And if there's only one x-intercept and it's the vertex, then you don't look for them either. But only if there are 2 x-intercepts. I don't know where it is. There will be. Oh, there's a typo here, gang. Wait, no? No, we're good. Only if there are 2 x-intercepts do you actually go through the process to try to find them, either by factoring or with the quadratic formula. Either way, okay? And then you still find the symmetric point to the y-intercept. That's the same, right? So ultimately, we're still looking for the same 5 points. You want the vertex, you want the x-intercepts. There's often 2. You want the symmetric point to the y-intercept. What am I missing? Vertex, x-intercept, x-intercept. Oh, the y-intercept, and then the symmetric point to the y-intercept. So we still want the 5 points, but it's just a better way to get them, okay? All right, the only other thing to say about this demo before you jump in on the activity is that number 5 here, it says, it's often useful to determine the smallest and largest value a quantity can assume. For example, a company might try to minimize its costs or maximize its profits. Both seem reasonable, right, for a business to do. And so suppose that the profits of a company are a parabola. It looks like this. Everybody look up here. Suppose that this thing right here, over here, everybody over here. Suppose that my parabola with my hand right over here is the profits for producing, like some bicycles. We're going to sell some bikes. Okay, so where's the maximum profit point? Well, it's up here, and that guy has a special parabola name. What is that called? That's the vertex. And so if I say, hey, figure out how many bikes we should sell to maximize profits, you just need to translate that to, oh, Ian just wants me to find the vertex, right? But I'm not going to be straightforward like that. I'm going to say find the maximum profit, and you need to translate to, oh, it's just the vertex. And suppose that now it's this kind of thing, and this represents the costs to the company for selling the different bikes. And so in this case, the company wants to minimize the costs. And what's the parabola word for the minimum point on this parabola? That's also the vertex. And so if I say find the minimum costs, you translate that to, he just wants the vertex, okay? And so you're going to have your radar up, and you're going to be looking for any one of these words: maximum, minimum, biggest, smallest, highest, lowest, least, greatest. Any synonym for any of those words, you translate to vertex, okay? So you look for one of those words, and then you say, hey, he just wants the vertex. Okay, so the activity is on the next page. You're going to jump in there.